Hey guys, welcome back. Let's go ahead with another problem that we're gonna solve using recursion. So the problem is finding out if a given binary tree is a subtree of another binary tree. So before jumping into the discussion, I want to tell you one thing that this problem just needs you to know that how we exactly traverse a binary tree. If you know that, you exactly know how to write the solution. So it is, I guess, very simple to understand the problem. We will be having two trees, let's say tree 1 and tree 2. We have to check if tree 2 is a subtree of tree 1 or not. And as you can see, this tree here is actually a subtree of tree 1. So our function must return true. So this was the problem statement. Now let's talk about how we're going to approach this problem. Approach we can take is first we can traverse and store the elements of both the trees in separate arrays in a particular order. For example, in order. In order, the left child comes first and then the node itself, and at last comes the right child. You might know there can be some other order too, like pre-order, post-order. Pre-order means that the node itself comes first and then its left child and then the right child. And you can guess post-order means node coming at the last. First the left child, then right child, and then the node itself. So after traversing these two trees and getting the arrays for both the trees, we check if the smaller tree is a subset of larger array. So here the recursive strategy is only needed for traversing the trees. So if the in order of tree 1 and tree 2 are these arrays, then you can say that this tree 2 is a subset of tree 1. But that's not always the case. Nodes with same value arranged in different manner may also produce a subset of in-order set like this. But this is not the subtree, right? So for that, we need to take another traversal to validate the same. So along with in-order, we also need to find either pre-order or post-order for both the trees. So in this example, if we check the pre-order for this tree, then we find out that clearly it is not the subset of the pre-order of tree 1. Whereas if given binary tree is a subtree, both in-order and pre-order arrays of given subtree will be subset of the main tree. So how are we going to do these traversals recursively? Or how are we going to write the solution using recursion? If we are going to go with in order first, then first we need to go to the left and then to the node itself and then to the right child. Similarly with pre-order, we first go to the node itself and then the left and then the right. So let's have a dry run to the solution. Remember all the steps, first identifying what the function should do. So the function is, let's say, in order. It will take the tree and will return an array, right? As we mentioned this. Same with pre-order. Next is picking a subproblem and then assuming that function already works on it. Subproblems for a tree are its subtrees because it's a recursive structure, remember? So how are we going to break this problem up? We'll first traverse the left tree at every node, then the root, and then the right in case of in order. So first traverse the left node, which again is a tree. So this in order function call recursively traverses that tree and adds the nodes from that tree into the array or the list, and then comes the node itself and it's get added in the array, and then comes the right node, which again is a tree, and this recursive calls makes that happen again. Now the same goes with pre-order. The difference is just in the order. First comes the node and then the left and then right. Okay, now the third step is using the recursive steps and constructing the solution for the original problem, and that we already did here. To construct the original problem, we just needed to read the current node, and other nodes are just being read by these calls. So the third step is complete, and now comes the base case, the fourth step, which is identifying the base condition. If the current node is null, then simply return from there. That is it. This is the recursive code. Now we just need to check if the array 1 contains all the elements of array 2 or not, in both in order and pre-order. And they should be consecutive. So here we can get the string for both and go for substring method. That's it. Now let's talk about the time complexity of the solution. If the length of the first tree is n and the length of the second tree is m, then the complexity will be O n plus m, as it is going to meet each node only once. So it's O m plus n. Now let's move to the IDE to try out the solution.